Up record while we get some, so you have some reference. So I got 13.4. I'll just call that 13 and a half, just to round it off. Rounding it down to 13 might be a little bit silly. Say that again?
It's a half state?
A half a state, on average. What does that mean? Why is that okay?
Well, Delaware, is that like a half state?
Easy. Buddy. This guy's centric, the entertainer. No. So, why is it okay to have a half a state on average? Because it's an average. You're distributing evenly, and if it doesn't divide evenly by the 27 or so states that we had, you're going to have fractional values. I mean, technically speaking, we probably should round it down to 13 to use sig figs, but we could have the filler comment. That's much more fun. Okay, so and that average, since it is a perfectly even spreading of the data evenly, so in other words, if we have our 363 states total visited, if we each went to 13 and a half, we all still visit 363 total states. They've asked, when you ran the numbers before, what did you get as far as a sum total? And I ran 353. Now it's 363 if we add the 10 in. So of 363 total states, if we divide that by 27, that means we all get 13 and a half states. Thinking of it from a pure average point of view. Remember, in 1990, 2.5 children per family on average in America. 2.5 children. That just means that every 10 families, there were 25 kids. Averages the 2.5, doesn't literally become the 2.5.
You just have 3 and cut 1 in half.
Or that. Or you just have 3 and 1 and 2 and another and call it 2.5.
Oh.
It's like a good use. It's a good use of the head in the oven, foot in the fridge. It's a good use of that numerical. It's a good use of it because it's numerical. It's not qualitative.
Now, see, I'm getting 13.4, so would you drop the 4 off?
Let's just call it 13. Call it good. Let's just call it. I was trying to get to a nearest half. We'll just. Damn it, Corey, you win again. And what should that average have with it? What should that average have with it?
States is.
Well, we say, well, go unit-wise, right? States, absolutely, Corey. But I was thinking, what measure should accompany that 13 to give us some idea? Yes, the plus or minus, Tammy. And what is the plus or minus on this? The sample standard deviation. What is it numerically? About 7 states. Why is that important, friends? Why do we care about that 7 with the 13? Why do we care? Other than the fact that I just give you points for giving it to me in your exam, which is the lamest reason possible I can think of. But
the margin of error.
It gives us an idea of the margin of error, right? We build up this idea of a margin of error around it. And if we know that data is shaped a certain way, we can tell a certain bit about the data set with that margin of error, that standard deviation, can't we? Let's do this. Let's take a look at our data graphically in a histogram. Let's fire up our machines. Okay, here's your sample stats. There's our 7, which is the plus or minus around our 13. Okay, let's remember how to make a histogram of our data. So, remind me, how do I get a histogram out of this monstrosity? That's okay, that's why I like going over it again. This is why I like going over this every day if I can. Second y equals, Tabitha. Second y equals gets us to our stat plot menu. Second y equals, yes?
Enter.
Enter gets us to plot 1.
Turn it on.
Turn her on. Select histogram, which is already on, because we've been doing histograms quite a bit, so it should already be selected there.
I don't need frequency of taking that out.
Well, when you say take it out, I agree, Athena, but make sure there's a 1 there. When you say you don't need frequency, you don't need a list as a frequency, but make sure there's something there because it has to know how many times to count L1. So count it 1 time each. If anybody has L1 and L2 like this, which I think most of you probably do, if you try to go down there and type 1, what happens? You get Y. Do you remember Y? You're on alpha. It's a bug. It's a bug. So we hit alpha button, we hit 1, and this is what our screen should look like now. Plots on, histogram, data is in L1, count each data point 1 time. Yay us. Okay, what's the quick and easy way of getting right to the histogram we want? Zoom. And then 9. Zoom 9 gets us right there. Boom! There it is. Now from here, personally, I like to mess with it a little bit. I like to kind of finagle the window. It always sets it up so you have 7 spaces, and it subdivides up your data accordingly. What I like to do is just go into the window button and just mess. So I know the data is the number of states we visited. So I'm going to change xmin to 0 and xmax to 50. Because that's kind of my realistic range of values, right?
Isn't there 52?
No. 50, I believe. What's I always thought was interesting in how to set up the little stars on the flag. It's very, if we ever add a 51st, they're gonna have a hell of a time making symmetry.
Oh.
Right, think about that. They're gonna have to get really clever with the 51.
That's why we haven't
Before
done it
it
yet.
goes up.
Well, 49 would be cool, like 7 rows of 7. But then you have 50, like, oh, how'd they do that? Oh, look, very clever, alternating rows. So 51, I don't know. I don't know why I'm telling you this right now.
Yeah.
Anyway, as far as the scale goes, 5 is a good number because then it goes 0, 5, 5, 10, 10, 15. So if I just press graph now, I get that. Now notice what happened. Does your guys look like this too? You're gonna spike off the charts, but that's okay. Change exactly. You need to change your window. In which case, what am I gonna change right now? Actually, Y max. It's going. It's off the chart here, which means whatever this number is right here, which is 9.36, is not high enough to capture all those numbers. So I'm just gonna start experimenting. I'm just gonna make it go up to 20.
No, 20's too much. I'll try
20 is too much.
Yes.
15. Try 15. Okay, then I'm listening to you guys. And I'm going to scale it by 3s. That's not relevant either. There we go. That's not bad. That's a slightly skewed distribution, but I'm going to call that, actually, would you call that bell-shaped? I would. It's slightly skewed for sure.
Yeah.
It's slightly skewed. A little bit of a tail over here, but it's got a classic bell shape. But that was a little hard to see originally, wasn't it? When we went to the original window, Zoom 9, that's what we saw. So because of the way the data is grouped, that's harder to see that it might be bell-shaped, right? That's why I like messing with the windows. I like taking a couple different looks at the data and seeing, okay, that doesn't look bell-shaped. But that's because the TI is grouping this thing by 5, starting from 3 and going to 38. Let me mess with the ranges a little bit. Let me play. And that's why I like doing this every day, because as Kelsey said, I don't remember how to do this, even the button pushes. But I want to make that second nature to you, so then you can do it rapidly whenever you want to. So I'm going to go back to what we had, 0 to 50. Scale of 5, this was 15, and then there we go. So we're going to call that a bell. We're going to call that a bell. Looks pretty, there we go, looks pretty good. All right, with me so far? That's the one hop right there, the 4. We have a 4, and we've got, that looks like it's too high. Oh, 3 and a 4, that's it. So now, actually, I'm doing something automatic I should be talking to you about. I was trying to make peace with this bar right here being too high. 2, as in the number 2, not 2 like 20200. So I'm looking over there and trying to see the numbers. Your TI can do this for you. What sucks about this is there are no numbers on it. So the only way to get around it is by pressing the zoom button, which is, excuse me, the trace button, not the zoom button, the trace button, which is right next to the zoom button, to the right of it. And as soon as you do that, it puts you on the graph, and then it tells you how many numbers it has between these two values. So this tells you, I hate the fact that it uses n. This drives me nuts. I wish it used f. Because little n, we're used to using little n as the entire set, but it uses n here, folks. I'm used to that. So there are 2 numbers that are bigger than 0 but less than 5. So equal to 0 or bigger, less than 5. There are 2. That's why I was scanning over there. Oh yeah, there's a 3 and there's a 4. So those are our 2. If I scooch over again, there are 5 that are at least 5 but less than 10. If I scooch over there, we can find those. Those 10s, by the way, are not in this. Those 3 10s, including the one that, tell me your names again, Francesca, you told me I had the 10, right? Those 10s are actually in this next bar. And do you see why? That's strictly less than, not less than or equal to. So this, Dave, your question from earlier about when you have that bar that abuts up, this takes care of that by putting the equals part on the next bar up. So those 3 10s that we see there would actually be indicated in that bar right there. And we scroll on out, Over here we have some 1s. We've got one between 25 and 30, which appears to be the 25 right there in the bottom left corner. And then one between 30 and 35, which would be that 33 in the third column 2 down. So again, we lose a little bit of precision because we don't have the raw data, but we get an image of the data. How many of you could look at this and say, yeah, the data is roughly bell-shaped? I mean, it's right, it's almost impossible to do. Hell, I can't. I've been doing this stuff for 20 years, I still can't do that. I need to see that grouped and pictured out like that. Fair enough? Do we have a mode? It looks like 10 might be it.
I think there were 2 modes.
Oh, there are 2, and 14. Yes, look at that.
10 and 14.
We got a bimodal distribution, 10 and 14. Pretty slick. Thank you to the 10, exactly. We had a quad modal distribution in early class, which is ridiculous. Yeah, 4 different numbers there. And that's why I put mode in parentheses. The mode can be goofy. I mean, you could have a really defined average and median, and then the mode can be nothing like it just by virtue of the way the dice shook out. So we could just ignore it. It's not that important in this case. Honestly, there's not much math we can do with it. I mean, in general. So it's a great way to give you guys 3 points on an exam. Otherwise, we tend not to analyze it very much. Did you find a median for me, friends? Sorry, Michael. Yeah, over here. 13?
Yeah.
13 states. Okay. Which matches the average. Did you expect the median to match the average? This is a bit of a loaded question. It's something we brushed on about a week and a half ago. What's the shape of the data?
Bell.
Remember what happens in a bell-shaped distribution? The average is in the middle, and the middle as in like from equal from left to right. Where's the median? Right, they match. They tend to match, which makes perfect sense with a bell-shaped distribution. That's what you would kind of expect. It didn't happen early today. Early in class today, we had a distribution that was highly skewed with a long tail and an outlier popped out here, and the average was about 3 states to the right of the median, which is indicative of the fact that the average tends to head out towards those outliers. So, perfect. You guys are less skewed than the earlier distribution. Excellent. Now, there's a reason. I'm going to turn this off for a moment. There's a reason I separated. These guys we'll get to in a second, I promise. These guys up here, I like to call these, make sure you can see this on the camera. I like to call these top guys measures of absolute, and this is just what I call it, absolute position. Because given a data set, those 2 numbers up there essentially are formed from each other. S has to follow X bar. You have to calculate X bar first and then use that to measure the distances away from it to get S. And X bar itself is an absolute value, not used in the mathematical sense, but in the literal sense of what an absolute number is. Based on the entire data set, it's that sharing value that Cassie mentioned before. The guys that we're going to talk about today down here, I like to call these measures of, I like to call them relative position. And that's what I want to kind of focus on today. Not that the average and the standard deviation are not important, because they are important. But as you saw yesterday, and when I say yesterday, I mean Monday, of course, because I get my Tuesdays forgotten sometimes. We see that sometimes you do encounter relative position measures. In the context from Monday, it was Max going to his 2-year-old doctor's checkup. And when Jen brought the data home from the 2-year-old checkup, did she tell me Max was 31 pounds? No, she handed me a chart that said Max was in the 80th percentile. So I want to come back to these in a second, but I want to also put down here at the bottom percentiles, which are also measures of relative position. Do you remember what a percentile is? From our discussion from Monday.
It's the proportion of data a given point receives.
Very nice. So when we said Max was in the 80th percentile for weight,
Killed it.
killed it in what way?
Beat 80% of them.
He's heavier than 80% of those kids. Killed it. I like that. 90th percentile for length. He's longer than 90% of those kids. 85th percentile for head girthier than 85%. So that's what it means. It's basically a percentage that your data point is larger than. Everybody right now, find your number in that chart and calculate your percentile. Calculate. You're all going to have something different, except that all of you that have 10 will have the same number. And let's agree on a definition. Strictly greater than. Strictly greater than. So if you're one of these 10s, you're only counting 9s and belows as you're bigger than them. You're not counting the 10s. Does that make sense? I'll shut up now and let you talk. See that? Yeah, go to your list. You might want to sort your list, that old trick we did last time with the sort. Stack 2. Remember step 2? Sort ascending. That might help you. We'll just count real careful, like. It works too.
Sean, I didn't catch, which one was Oregon?
Which one was?
Oregon.
Each one of those is a student and how many states they visited. So where were you? Where are you, Dave?
I'm probably at 3 states.
You're at the 3? So you're in the 0th percentile.
Okay.
Actually, in 3 states,
I was 4th.
you were 4th. So how many did you beat, Lucas?
1 person.
1 out of 27, I believe, if I'm counting correct. So your percentile is the 127th, whatever that is as a decimal. It's just shy of 4%, I think. You're 0th percentile, nothing to count. Now, and we'll talk about that more in a second. So Lucas, you got about what, like 3.5%, something like that?
Hold on.
Oh, you're still doing it. You're still doing it. There will be no one at the 100th percentile. Even my friend who had 33 states visited. You're not in the 100th percentile, are you? You can't be.
You can't be bigger than yourself.
Exactly, because you can't exceed your own data point. So that 33, my 33 state friend, is going to be in the 26 divided by 27, whatever that is as a decimal percentile.
Okay, so how do I determine if there's two 15s, what percentile?
Just count the 14s and below.
Okay.
So if there are two 15s or three, four, all these 14s, where are my 14 friends? 14 state friends? Yes, you guys right there. You ignore the other 14s. Just count the ones lower than 14. 15, lower than 15, and so forth. Let's hear some. Let's hear some percentiles. 55th percentile. That's just about in the middle. That's just about in the middle. Now, the median we had was 13 states, so that means Tabitha was in the 14th. So she's just above that. Eric, go ahead.
Out of 27.
Eric's 27th.
No, wait, no, I said it's out of 27 now?
Yeah, because I've got 5, 10, 15, 20, 25, and then 2 is 27. I try to be a little bit organized with how I set it up. Oh, I should have done 3 by 9 rather than great. Oh, well. Oh, I didn't know it was 27. I thought it was 26.
Late entry. Yeah.
There we go. So let me hear some other ones. 88th percentile, 0.5. This is great. You can get as much precision as you want, 88.5 percentile, or just round it off the 89th percentile. Technically speaking, I think the way textbooks describe it, I mean, this is the way I want you guys to think of it. It's the proportion of the data that's exceeded by whatever data point you're interested in. That's what I want you to think of it, because that's kind of the classical, simplistic way of viewing it. A lot of textbooks will say all these percentiles from P sub 1 to P sub 2 up to P sub 99, they split up a data set into 100 regions. You can split it up into way more than that. But the classic thought of percentile, 100, kind of exists there. 88.5. What else we got? 85. 85th percentile.
93.
3.5? What was yours, Lucas?
4.
4th percentile. And as a shortcut, as a shorthand way of saying this, like for example, we just found this guy was the 4th percentile.
No.
All the 14s? No.
No, that's me. He's the one.
Oh, Lucas! I'm sorry. Lucas was the 4th percentile. I'm sorry. Here we go. Lucas is down here. Right.
Here you go.
Oh, Dave, you weren't 3.
No.
Cassie was 3. Now, Cassie, what did you end up being?
I don't know. It was 3. I thought it was 0.
Well, you visited 3 states.
Oh, okay.
What's your percentile ranking? She didn't exceed anybody.
No, right.
So technically speaking, that's the 0th
You're
percentile.
right. Okay.
Right, that's a 0th.
Yeah, doing it.
It's a simple, don't overthink this. It's simply number of those you're bigger than divided by how many there are. That's all this is. So basically, 1 out of 27 is somewhere in the neighborhood of like 3.5%. Every additional number you increase that numerator, you pick up about 3.5. So that's why Lucas is about at the 4th percentile of 4. He beat the 3, which is roughly 3.5, rounded up to 4, that's totally fine. 14, Tabitha, you said you were the 55th percentile, is that correct? This is P55.
Then all the 15s are at the 63 percentile.
Say that again, Athena.
All the 15s are at the 63 percentile.
These are the 63rd percentiles. Beautiful, where are they? 15s, here they are. P63. Shelby, you were at the 88.5th percentile, and you were what?
24.
20, I was looking for the 20s, right? Here we go, these 24s, the 80, I was going to call it P89 if it's okay with you, rather than off the nearest whole number. And so you're getting the idea of this, Why do I like to call it relative position? Because it's your score relative to everybody else. It's how your data point is relative to the rest of the data set. It gives you an idea of that relative position. You're not ranking it with respect to sharing, you're ranking with respect to ranking it. So relative ranking, kind of that idea. So that's percentile. And percentiles are great. Every one of these numbers has a percentile attached to it, and they're all wonderful. However, it gets a little bit overbearing because it's like almost like a too fine-toothed comb. You've got all these different percentiles floating around. So very often we use things that are called quartiles. You may have noticed when you ran your TI, let's bring this back over here. You may have noticed when you ran your TI 1-bar stats, Okay, everybody run one bar stats again if you didn't already. So there's our average, there's our standard deviation, there's our 27 data points. This screen is great, and we spent most of our time in the screen so far. Go to the bottom of the screen, which is where your median lives. Yeah. These are your relative position measures. Now, your median, although we've already talked about them, is indeed a relative position measure. 13 states. What is the median again, friends? Middle number, how? I love that. Geographic middle. What do you have to do to find the median? Right. What do you have to do first? Put them in numerical order, and you end up in the middle. So what you end up doing is you end up chopping off the bottom 13 in this case, and the top 13, and you're left with the 14th data point in order. You just found a percentile, didn't you? What percentile did you just find? Say it again, a little bit louder. You found the 50th percentile. If you chopped off, chop, 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 chop. When you're done chopping and you're sitting in the middle, you've chopped off the bottom half of the data. Which means the number you're sitting at is bigger than the bottom half of the data. Which means it's the 50th percentile by definition, right? It's exceeded half of the data. So this median right here, of 13 states, is technically called the 50th percentile. Sometimes, and I say this extraordinarily rarely, it's called the second quartile. A quartile is just kind of a looping together of percentiles. So the second quartile would be 0 to 25, 25 to 50. So you're jumping, instead of by ones, 1, 2, 3, 4, 5, you're jumping by 25s. Does that make sense?
Yeah.
So the first quartile, which you're seeing right here at 9, is going to be which percentile?
25.
The 25th percentile. So this tells us that it's 9 states. We'll come back to why all this makes sense momentarily. We're going to actually draw this up in a dot plot and take a look at it. And the third quartile would therefore be the 75th percentile, and that tells us that it's 16 states. These are all in states. It also gives you a min and a max, which comes in handy in a little bit. We'll deal with him. I think you guys can figure out what that means. So those are the other measures of relative standing. What I want to do is I want to drill home what each one of those measures now looks like when we take a look at kind of like a meta look at our data set. So what I want to do right now, let's turn our TIs off momentarily. Okay, I want to go back to just the board. And I want to draw our old friend the dot plot. So I'll do it over the sideboard here. We're going to sketch out kind of like what we did on the TI with the histogram, but let's make a dot plot so we actually get all of our data up onto the graph. Does that make sense? We haven't done a dot plot in a little while, so I figure we'll do it now. All right, so let's go here. Oh yes, I know it's been a while. And I wish the TIs would do this, because a dot plot combined with a secondary graph is a really, really, really slick way of looking at this. So it's okay, we can make it work. We'll go 0, 25, and 50. We'll break it up 5, 10, 15. No, that's not right.
Yeah.
Let's do that better. 15, 20, 25, 30. No, 30, 35, 40, 45, 50. Pretend those are roughly even. Remember a dot plot now? We're just going to add a dot for every occurrence of the data that we see. So first one's a 12. Put a 12 here. 24. Oh, thank you. Yeah, you guys mind calling them off? That'd be great. 14. 3. 6. 18. 10. 33. 15. 10. 10. 24. 7 is right here. 5. 4. That was a 3, right? Yeah. 20?
Yep. 11. 9.
Is that a 12 or a 11?
That was a 12.
Thank you. There we go. 12, 13, 14. Sorry. I'm not being up. Okay.
16.
16. Sorry, you're being very patient, Fiona. I appreciate that.
13.
13.
13. 12.
12.
25.
Now you're just getting condescending a little bit.
No.
No, you're not kidding.
6.
Totally kidding. 6.
15.
15.
14.
14. 13. Thank you. That's fantastic. So it's like an uber meta histogram. And that's not even a real word. I made that up right now.
Yeah, you did.
Totally made that up. So the reason I like this versus a pure histogram is now we get our raw data plus a shape. So we have the shape plus the raw. It's like we have the histogram without having to sacrifice any precision. Let's find the median. Let's find the median again on that graph. Now we know it's 13 because the TI told us it was 13. But let's think the way Shelby had us find it. But let's go one further than that. I know there's 27 data points, and I know I've got to find the point halfway in between, which would be the 14th spot. See if you can buy why that is. 27 points laid up in a row. I got 13 on one side, 13, oh, that's 26. If I remove 13 and 13, I've got the one in the middle left. It's got to be 14 in from one side or the other. And it doesn't matter which side you come in from. Tabitha, go ahead.